everyone. Since Professor Lee has additional work this week, so I will teach him today's and tomorrow's course. Okay. Okay. So my name is Wen Xiaochen. You can call me Dr. Wen or Dr. Ken. It's okay. And I'm a postdoc researcher in the Department of Civil and Construction Engineering. And my main research focuses on geotechnical engineering, like soil mechanics, rock mechanics, and foundation engineering, slope, landslide, quality improvement, and earthquake engineering, like soil liquefaction and the retaining structure of tunneling, like this. And okay, in civil engineering or geotechnical engineering, experience is always our master valuable asset. Therefore, we often learn from disaster. So let me give you two cases of my significant research project. Okay, this is a construction site collapse disaster in Taipei City. So it occurred on the night of the September 7th, 2023. After the construction site collapse, it affected the near order apartment building. So you can see. Okay, only 7 seconds. The building will segment. So instead the first floor will order apartment become the basement and the second floor will become the first floor. But unfortunately, no one was injured because we know this construction site will collapse. However, how do we know that this construction site will collapse? Okay, the reason is we hear the many sounds before it collapses, just like this video. I think this case is very amazing in Taipei City. Okay. And although this video start recording only after the collapse began, and what I want to explain is that this case shows a situation where the structure initially reached a steady equilibrium, but the material cannot withstand the force loading to value. This is why we need to study static first, so that we can calculate the forces acting on material when a structure is stable and ensure its safety. Okay, this is the photo taken after the construction site collapse. Normally, before construction begins, we must complete a geotechnical investigation, get the soil and rock specimens, and take them back to the laboratory for testing to determine the material properties. Only after that, we do the process with design, analysis, and check everything. This construction site did not fully adhere to this process. The designer over estimated the strength of the soil, resulting in a weaker structure design. Ultimately, this led to the disaster. Okay, and this is second case about the road subsidence disaster.
道路の貨物が大きな作業
So we can see it's like a sinkhole.
長さ10メートルほどの
The track fell into the
貨
hole.
物を目撃した女性
So this hole, I think, is very big because the track in this hole.
走行中だったトラックが貨物に巻き込まれて落下した取り残された運転手の救助活動は陸路が中断を余儀なくされ難航しているその理由は
Recently, similar disasters have occurred in urban areas of many countries, such as Japan. Okay, this case happened in Japan, and South Korea, Malaysia, Brazil, and even Taiwan also happened like this. And you can see when the track was a second hole appeared. So it's very dangerous. Okay, and why do we think the cause of such disaster? What do you think about this? What happened? Okay, the answer is when the pipeline ruptures, so the soil begins to flow into the pipe, causing underground cavities to gradually enlarge. Once the cavities grow to a certain size, the road will eventually collapse. So the key issue is the rupture of the pipelines beneath the road. Okay, and this is a sandbox simulation in a laboratory setting. Okay, if we create the hole at the bottom, this is like a road, and we have the hole at the bottom. We assume the pipeline rupture. The situation we just discussed with Parker. Eventually, the road will collapse. So you can see. Like this. So this is in laboratory do the simulation test the result. Okay, and the event has already occurred to prevent it from happening again. We can predict where it might occur. We can take preventive measures. However, how should we predict it, and what is the extent to the impact after it happens? Okay, so my team is using AI and machine learning to quickly predict the good of pipeline ruptures, and the road collapse in other location like case data such as pipeline, soil, groundwater table, and more. In addition, my team also used the numerical analysis software to simulate the event process. By performing a numerical simulation, we can get the range, this range, and the depths of the road successes under various scenarios, as well as the value of soil loss also can get. Okay, I hope my sharing can spark interest in civil and construction engineering among some of the students. So now, let's return to the course in order to conduct engineering related research for fundamental understanding of mechanics is essential. Therefore, this course is very important. It is the foundation of all foundation. Let's review co-planar force system. Okay, a system of object reaching a state of release of equilibrium is called a stasis. Okay, so co-planar force system is two-dimensional concept. As long as we can calculate the force acting on each component in the x direction and the y direction, we can apply the concept of equilibrium. And please note that we must first set the origin. Okay, so we can set origin first. Set origin first, which is the intersection of all force. The directions. Only then can we begin calculating static force and deformation. Okay, so let our review this example. The 200 kilogram created in this figure is suspended using the ropes AB and AC. Each rope can withstand the maximum force of 10 kilonewton before it breaks. If the AB always remains horizontal, please determine the smallest angle to which the plate can be suspended before one of the ropes breaks. Okay, so we can draw the free body diagram first. Okay, so first one we set the origin. So we set the origin at the point A, and in this diagram we can see we have the three force part. First one is the loading. So the loading equal FD is equal to 1,962 Newton. And we also have the force FB. The FB force parallel direction on x-axis, and FC force. Okay, then because the road next more, I think the tension force need smaller than 10 kilonewton, so we need to check. Okay, so FD is equal to 1962. Okay, so checklist is okay. Then we do the equation of equilibrium. So x direction, is dimension fx is equal to 0. So we can check fc. fc is negative x actual. So we can use the minus fc times cosine theta, then plus the positive x actual fb. So plus the fb is equal to 0. Then we can do the sum search. We can get this relationship. Okay, in y direction is the summation fy is equal to 0. So we can use the fc times sine theta, then minus the fd is 1962 Newton is equal to 0. So we can use the equation 2 and get the fc result. Then put the fc result in the equation 1. Then we can okay, sorry about it. Because the fc always how to say fc always less bigger, no, always bigger than fb, because the cosine since cosine is smaller than 1. Okay, since cosine is smaller than 1, cosine theta is smaller than 1, so we can set the fc. We can set the fc is equal to 10 kilonewton. Then we can get the theta. So we can get the theta first, and put it in equation 1, and fc we set the 10 kilonewton, and put it in equation 1. So we can get the fb is equal to 9.81 kilonewton. Okay. Okay, we introduce the next example. Okay, this example is determine the required length of the chord AC. So we need to determine the AC length, and a kilogram length can be suspended in the position shown this like this, and unfold length of the spring AB. So AB is a spring, and the unfold length is equal to 0.4 meter. And the spring has a stiffness of KAD is equal to 300 Newton per meter. So we can draw the free body diagram here. So first we set the origin at the A point. Then we have the three force. First, the loading. So the loading is equal to A kilogram, but in force it becomes Newton. So we get the loading force is equal to 78.5 Newton. And we know the TAC force, the angle is equal to 30 degrees, and we we calculate force TAC and the force TAB first, then we can calculate the extent in the AB spring. And we can get because we know the total length at here, so we can calculate this distance and calculate the AC length. So we can use some equation of equilibrium in summation fx equals to 0. We use the TAB minus the TAC cosine 30 degree is equal to 0, and the y direction equal to 0, we can use the TAC times the sine 30 degree this direction, and minus the loading force, so 78.5 Newton. And then we can use the equation 2, this equation, to calculate the TAC first. Then use this result into the equation 1, then we can get the TAB result. Okay. If we have the TAB result, we can use this equation. We have a KAB is equal to 300 Newton per meter. So we can calculate the SAB is equal to 0.453 meter. Okay, so we can calculate LAB, length AB. Original length is 0.4 meter, and plus extend length 0.453 meter. So total length is equal to 0.853 meter. And from this to this distance is 2 meter. So we can know the length AC times the cosine 30 degree is this distance. So plus the 0.853 meter is equal to 2 meter. So we can calculate the LAC is equal to 1.32 meter. Okay. Okay, so this is other example we can exercise. Please determine the magnitude and describe the theta of F so that the particle is in equilibrium. So we can set origin here. So we have the force, and we know the use the ball. We draw the diagram. So we have the four part force, and we can call this is force A, force B, and C, and D. So we do the x direction summation x fx. First, we use this part, FA. So FA sine theta and plus FB and minus FC. Equal to 0. So we know the FA times sin theta is equal to this number. And next is summation F y is equal to 0. So minus FA first, use the cosine. No FB because FB only at the direction x. And also minus FC. We also can get FA sine theta is equal to 4 minus 2 square 3. So we have the two equations, this and this, but how to calculate the theta in the FA?
Right?
Yeah. This divided by this, then we can remove this FA, so only sin theta and cosine theta. Then we can sin theta divided by cosine theta is tangent theta. So we can get with the tangent, then get the theta. When we get the theta, we can use this equation or this equation to get the FA. So we can write down this step here. So we can remove this part and this part. This part. This tension. Sit. Equal to this. So we can get the theta. Use our tension. The answer is this 82.23 degree. And we can put to equation 1 is okay, and equation 2 also okay. Then we can get the FA. FA is equal to 3.96 kilonewton. Okay. So next question. Determine the tension developed in wells CA and CB required for equilibrium of the 10 kilogram cylinder, and we take the theta equal to 40 degrees. Draw a diagram first. Okay. And origin at point C. Okay, so this is origin point C. Okay. So we can do the equation of equilibrium. Okay, so it's the FE sine 30 degree minus we can get the FB relationship between the FB and the FB. And with dimension F1 FB sine 43 plus FA and then minus the loading force, so 0. And the loading force is equal to 10 kilogram times 9.81 Newton. So we can use this relationship, put inside, then we can get the FA. Equal to 79. And we can get FB is equal to 1941 Newton. This is answer. Okay, then same diagram, but okay, so this example said the cable AB the tension is twice of the cable CA. So CB is twice CA plus CA. Then we need to determine the C. So summation Fx you know this, so also equal to 2. So we can remove this part and this part. And we can get the C. Is equal to 64.34 degrees. Okay, then we need to calculate the FA and the FB, so we use the summation FY. Loading force is equal to 10 kilogram times Newton. So, and the seat we have the answer. And okay, and FD, we know to FA. So we can get the FA 42.6. Then because the FB is twice FA, so we can get the FB. Wow. Okay, so I think